The solar system has a new member, and it is calling into question theories about the much-debated Planet 9. Using the Subaru telescope's wide field of view, astronomers have spotted a tiny far-off world beyond Pluto, one that could reveal how the outer solar system evolved into its present form. The strange object dubbed Ammonite was discovered through the Fossil Project. Observations in March, May, and August 2023 first picked up the object, now catalogued as 2023 KQ-14. By July 2024, astronomers turned to Canada, France, Hawaii telescope toward its predicted position, and fresh images confirmed the speck was still creeping along its lonely route. The team also identified older, previously overlooked sightings of the object in archival data from other observatories. This enabled them to track the object's path across nearly 2 decades. With nearly 20 years of motion now mapped, its path proved so remote and eccentric that astronomers placed 2023 KQ-14 in the elite Sednoid Club, a very rare category with only 3 other known members. Using the supercomputers at Japan's National Astronomical Observatory, the fossil team ran tests that trace its path. The simulation suggests that 2023 KQ-14 has followed a stable orbit for roughly 4.5 billion years. Yet today, it follows an orbit different from the other C-dodes, indicating that the outer solar system is more complex than previously thought. But most importantly, this discovery sets new limits on the hypothetical Planet 9. The closest 2023 KQ-14 ever gets to the Sun is about 71 astronomical units, which means that even at that distance, it is 71 times farther from the Sun than Earth. But since Ammonite's orbital path is highly elliptical, it gets as far from the Sun as 432 astronomical units, and it takes about 4,000 Earth years to complete one orbit of the Sun. Which means that when workers first laid the stones of the Great Pyramid, Ammonite had just begun the same 4,000-year lap it is now finishing. Fascinating, isn't it? One Ammonite year spans nearly all recorded human history. According to the lead scientist, it was found in a region far away where Neptune's gravity has little influence, and that implies that something extraordinary occurred during the ancient era when Ammonite formed. The fact that 2023 KQ-14's current orbit does not align with those of the other 3 C-dodes lowers the likelihood of the Planet 9 hypothesis. He added, "It is possible that a planet once existed in the solar system but was later ejected, causing the unusual orbits we see today." So, what does this mean for Planet 9? Well, Planet 9 might still be out there, just much farther from the Sun than first thought. It may even have been flung away long ago, leaving only its gravitational footprint behind. Another idea is that a passing star billions of years ago tugged Ammonite and the other C-dodes onto their unusual paths. This is exactly what another recent study showed. Our star system appears to be a calm and stable place. Yes, there are times that the gas giants occasionally nudge a comet or asteroid out of their orbits, sometimes even sending them hurtling towards the direction of the Earth. But overall things have been generally stable. But the Milky Way is estimated to contain around 200 to 400 billion stars with the solar system orbiting through the galaxy. While the distances between stars are huge in an ocean of these celestial fireballs, the chances of them coming close to each other cannot be ruled out. Now, around 75% of the stars in our galaxy are red dwarfs, typically having around 8% to 40% of the Sun's mass. The Milky Way itself spans a massive area stretching about 100,000 light-years across, with a central bulge roughly 5,000 to 8,000 light-year in radius. When calculating how often stars come close to our Sun, we consider factors like the density of stars in different parts of the galaxy, their orbits, and how fast they move relative to each other. On average, stars travel at around 20 kilometers per second relative to the Sun. Using this data, scientists can estimate how often stars pass near the solar system, potentially affecting our cosmic neighborhood. Calculations suggest that the closest a star has likely come to the Sun was about 500 astronomical units, roughly 10 times the distance from the Sun to Pluto. Such close encounters are rare, occurring once every few hundred 000 years. So, it's highly unlikely that a passing star will disrupt the orbits of planets in our solar system. But while encounters with stars won't often cause direct issues for planets, they may disturb the Oort cloud, a distant region of icy bodies surrounding our solar system. We know that gravitational interactions between stars and the Oort cloud are always happening, but their effects may not be visible for millions of years. Over time, Passing stars can send these icy objects hurtling toward the inner solar system, increasing the chance of cometary impacts. The last known star to pass close to the Sun was Schultz's star, which came near us about 70,000 years ago. However, a new research suggests that a star may have come closer to Earth in the Voyager probes. Our solar system may have had an incredibly close encounter with another passing star. Not one, but two recent studies propose that a stellar flyby could account for the strange orbits of certain objects on the outskirts of our solar system, as well as some of the unusual moons orbiting nearby planets. This encounter, according to the research, was astonishingly close. A rogue star passed within 110 astronomical units of the Sun, meaning it came 110 times the distance from the Sun to Earth. To give some context, this star would have approached us even closer than the Voyager 1 probe, which after being launched is now 164 astronomical units away on its journey beyond the solar system. Given that the nearest star to us today, Proxima Centauri, is more than 4 light years away, this was an incredibly close call. Such a near miss, the researchers suggest, would be necessary to explain the unusual and chaotic orbits of celestial objects located in the farthest regions of our solar system beyond Neptune's orbit. To investigate whether a passing star's gravity could be responsible for the unusual orbits of some of the trans-Neptunian objects, the scientists ran over 3,000 computer simulations. Their findings not only confirmed the hypothesis, but revealed something fascinating. The simulations showed that this stellar encounter could explain two of the most peculiar trans-Neptunian objects which have retrograde orbits, meaning they move in the opposite direction of the planets. It could also account for the distant dwarf planet Sedna, which orbits as far as 937 astronomical units from the Sun. A Myth-going co-author and astrophysicist noted that the simulations pointed to a star slightly smaller than our Sun at about 0.8 solar masses past, within a little less than 4 times the distance from the Sun to Neptune. Interestingly, this event could also explain the strange moons in our solar system, such as Saturn's moon Phoebe, which is a retrograde and distant orbit. Similarly, Jupiter and Neptune host several irregular moons that could have been trans-Neptunian objects displaced by the gravitational influence of this stellar flyby. This could explain why the outer planets have 2 distinct types of moons. Regular moons which formed along with the planets and have stable, predictable orbits, and irregular moons which have strange or retrograde, that is, backward orbits and may have been captured from the outer solar system. If this star had a close encounter with our solar system billions of years ago, it could be a remarkable chapter that may have been overlooked. But what if Planet 9 is still here? Astronomers have been looking for something big, something strange hiding far beyond Neptune. But spotting it is extremely difficult, as it doesn't show up in any images. But its influence is felt in the orbits of distant icy bodies. Scientists call it Planet 9, and they have been hunting for it for years. And recently, while searching for signs of this elusive ninth planet, astronomers stumbled upon something unexpected and extraordinary. This 2017, a newly discovered dwarf planet candidate. But it isn't just an addition to the list of distant dwarf planets. It might be pointing to something inconvenient, something that could contradict the very reason we started searching for Planet 9 in the first place. Astronomers have just identified what could be a new dwarf planet using observations from the Dark Energy Camera in Chile and the Canada-France-Hawaii telescope. The discovery wasn't made through a single lucky image, but by carefully analyzing 7 years of archival data, which revealed 19 separate detections, enough to reconstruct its orbit. And once they mapped it out, they found the object follows an extreme orbit. 2017 travels in a long elliptical path around the Sun. At its closest, it comes in at about 44.5 astronomical units, just a bit beyond Pluto. But at its farthest, it swings out past 1,600 astronomical units. For scale, that's over 50 times farther than Neptune, and one orbit takes about 25,000 years. That's not just far. That's outer or cloud territory. The object itself is estimated to be around 700 kilometers wide. And the interesting thing is it's not interacting with Neptune. It's just out there. No one's sure how an orbit like this even formed. One idea is that 2017 OFF 201 had a close run-in with something big. Maybe a planet that flung it into this stretched-out path. Now, over the past several years, astronomers have picked up on something unusual. A handful of distant objects beyond Neptune, known as trans-Neptunian objects or TNOs, weren't behaving the way you'd expect. Instead of having orbits pointing in all directions, a surprising number of them were aligned in similar ways. Their orbits were clustered, tilted, and stretched in the same general direction. And when that happens in space, it usually means something massive is influencing them, something we haven't seen yet. One idea was that a giant planet 5 to 10 times the mass of Earth was out there disturbing their paths. That's where the whole Planet 9 theory comes from. But here's the twist. 2017 does not follow that pattern. Its orbit is totally out of alignment with the others. And that is a problem because if Planet 9 exists and if it's a reason for the orbital clustering we've seen, then objects like OF201 shouldn't exist. At least not in a stable orbit like this one. In fact, simulations show that if you add Planet 9 into the model, OF201 gets kicked out of the solar system within 100 million years. So now we have a contradiction. Either this object is a fluke or the Planet 9 model needs serious revision. And it doesn't stop there. 2017 OF201 spends only about 1% of its orbit close enough to be seen, which means we may have just caught it at the right moment. And if that's the case, it could be just the tip of the iceberg, suggesting there might be dozens, maybe even hundreds of other objects out there with similar orbits and sizes still hidden in the dark. Right now, the dwarf planet is relatively close to the sun in the sky from our point of view on Earth. That means the researchers need to wait about a month or so before they can conduct follow-up observations, and they are also hopeful that they can eventually secure some time to scan the object using the James Webb Space Telescope. Till then, the possibility of Planet 9's existence is still on the table. Here's how. The simulations only use one specific location for Planet 9, but not all scientists agree on where the hypothetical planet lurks. In fact, Konstantin Batygin, one of the scientists who first proposed the existence of Planet 9, says that the discovery of 2017 does not prove or disprove anything. Speaking with NBC News, he said, "The objects in the outer solar system that are likely to show a footprint of Planet 9's gravity are the ones where the closest points on their orbits around the Sun are still distant enough that they don't strongly interact with Neptune. This one unfortunately does not fall into that category because its orbit is very chaotic." Meanwhile, Sehao Chang, who led the discovery of 2017 OFF201, said that he has not abandoned the hope of finding Planet 9, as the whole project started as a search for it. So, if you're holding out hope for a ninth planet in our solar system, don't give up just yet. In fact, a team of astronomers at National Tsinghua University in Taiwan may have cracked the code with an unexpected approach and could be closer than ever to its discovery. So, the object itself, Planet 9, could still be here, but likely is more massive than the Earth, probably a little bit less massive than Neptune. It sits right in between that terrestrial to giant icy planet range. Its orbit, unlike the orbits of the known planets, is not nearly circular and planar. Instead, it is exceptionally wide, 20 times bigger than the orbit of Neptune. It's just a tiny speck, a faint dot hidden in old telescope data from two sky surveys taken 23 years apart. And yet, this faint dot might be one of the biggest discoveries of our time. Because if this turns out to be what scientists think it is, it could be the long-rumored Planet 9. But why do astronomers even think Planet 9 exists in the first place? In 1781, an English astronomer named William Herschel was scanning the sky with a telescope he built himself. He was looking for comets, but instead he stumbled upon a new object that didn't quite behave like a comet. Over time, astronomers realized this object was orbiting the Sun like a planet. Slow, steady, and distant. They named it Uranus. But with more observations, astronomers realized Uranus didn't move the way Newton's laws said it should. Its orbit wobbled just slightly, but enough to raise eyebrows. A French mathematician named Urbain Lever worked it out with pencil and paper and concluded that maybe there was another planet pulling on Uranus. He even calculated where this mystery planet had to be based entirely on Uranus's strange behavior. And when astronomers pointed their telescopes at that spot in the sky, lo and behold, they found Neptune right where the math said it would be. Now, let's fast forward to 2016. Two scientists, Mike Brown and Konstantin Batygin from Caltech, noticed something strange. They were looking at the orbits of a few distant objects in the Kuiper Belt when they noticed a pattern. These orbits weren't random. They were clustered, tilted in the same direction, as if something massive was tugging on them. When Mike and Konstantin followed the data, it led them to a wild possibility. The only thing that could explain the strange orbits of these Kuiper Belt objects was a hidden planet. Something 5 to 10 times the mass of Earth, far beyond Pluto. So far, in fact, that we might never see it with visible light. They called it Planet 9. And ever since, astronomers have been on its trail, chasing shadows at the edge of the solar system. Now, the farther away something is, the harder it is to see, especially if it doesn't reflect much sunlight. So, to find Planet 9, scientists went digging through 2 infrared surveys of the sky. One taken by the IRS satellite back in 1983 and another by Japan's Akari mission between 2006 and 2011, which brings us to the latest development. A team led by astronomer at the National Tsinghua University in Taiwan did something clever. They looked for objects that showed up in both surveys, but not in the same place. The idea is that if something moved slightly between the 2 time periods, it might be orbiting the sun, just very, very slowly. Now, this isn't like tracking a comet blazing through the sky. Planet 9, if it's there, would be moving at about 3 arc-minutes per year. That is tiny. To put that in perspective, the full moon is about 1,800 arc-minutes wide. So, how do you even spot something like that? That's where parallax comes in. You know, when you hold a finger in front of your face, close one eye, then switch to the other, and your finger seems to jump sideways. That is parallax. In space, we use Earth's orbit around the sun to create the same effect. By observing the sky from different points in Earth's orbit, astronomers can detect slight shifts in the position of distant objects. And with enough time, you can use those shifts to estimate how far away something is and whether it's moving. Based on this, the team searched for objects that showed up in the same place at the same time every year, canceling out parallax. Then they narrowed it down further by checking if those objects were slowly drifting over time. And eventually they found one, a faint dot in the IRA's data from 1983 and another dot 47 arc-minutes away in the Akari data from 2006. Could it be the same object? Could it be Planet 9? Possibly, because based on its brightness in the infrared data, it would have to be more massive than Neptune. So what happens next? Well, if we know roughly where it was in 2006, we can try to spot it again with powerful optical telescopes. But here's the problem. In the years since Akari spotted it, this object would have moved. And we don't know where. But we do have tools that can help. The dark energy camera in Chile, for instance, has a wide enough field of view to scan the right region of sky. And soon the Vera C. Rubin Observatory will come online offering even deeper and broader surveys of the sky. So it's possible, even likely, that if this object is real and still glowing faintly, we'll see it again. But not everyone is convinced. Mike Brown, who helped propose the Planet 9 theory, took a look at the data himself. And while he doesn't rule it out entirely, he's skeptical because the orbit of this candidate object doesn't line up. Planet 9, as predicted, should have an orbit tilted about 15 to 20 degrees from the plane of the solar system. This new object's tilt looks more like 120 degrees. That means it's not just tilted, it's orbiting in the opposite direction from most planets. In Brown's words, that doesn't mean it's not there, but it means it's not Planet 9. What do you think? Just because we found something unusual doesn't mean it's the thing we've been looking for. Either way, one thing is clear. This mystery, whether it's Planet 9 or not, is going to keep astronomers busy.